Welcome to this course on PHP object-oriented programming. I'm going to assume that you have some fundamentals of PHP down. If you don't, check out our PHP for Beginners course. Now, what is object-oriented programming? It exists not just in PHP, but it exists in a lot of other languages. What object-oriented programming is, it's a way of writing and structuring your code to keep it organized so that it's more maintainable. This concept of maintainability, if you've watched any of my other videos, you've heard me mention this, has a lot of different dimensions. Let's talk about a few of these dimensions now, and we'll cover a few others as we start to introduce some object-oriented programming concepts. First of all, code bases that lack structure, that have files that have a lot of code in them, so they're really long, or code that's tangled together in unpredictable ways, it's hard to maintain. You can think of it as a plate of spaghetti. As I start to pull on one piece of spaghetti, it interacts with the spaghetti around it, and it starts to move those other pieces. In our code, we call that coupling. So when you have code that's coupled, as you start to change code in one place, it impacts code in another place. So you can spend a lot of your time chasing these couplings around. This type of code, you'll often hear it called spaghetti code. Another dimension that we see in code that's hard to maintain is code that's been copied and pasted. Because there's not an easy structure to encapsulate that code and reuse it, you often find that it's easier just to copy and paste the code. Now what happens is if there's a problem with that code that's copied and pasted, and it now exists in 3-4 different places. Now you have to go and find where that code is first of all, and then you have to make the changes in every single instance that you find. One particular challenge that I've seen in the PHP land is these functions have to have unique names. Globally, they have to be unique within your application. And so when you get environments like WordPress, which is written in PHP, WordPress has an ecosystem of plugins and themes that are written by third parties, and you can install these plugins and themes to add different functionality or change the look of your WordPress site. But if you're a plugin or a theme developer, you have to be aware that all the functions that you write have to have a globally unique name. So what I used to do is I used to prefix all of my functions with our company name. A lot of the times if you don't have that structure, you end up with these collisions of names. Those are just 3 dimensions of maintainable code. Object-oriented programming offers a way to write your code and provides that structure so we can avoid code that's hard to maintain. Before we get into writing any code, let's do a tabletop comparison of functional programming and object-oriented programming. Let's look at functional programming first. When you look at functional programming, we're really thinking of something like this, where you have a function and it has some input and you get some output. It's worth taking a look at a concrete example where a functional programming might evolve over time. Let's look at an example where we have to convert GPS coordinates, for example, lat longs, to an address using an external API like Google. Here's an example of version 1 of that application. We got version 1 marked over here on the left. I have my function. It says get address from lat long. I use snake case. You can use camel case or however you like to make your code more readable. I feel snake case is a little more readable for me. But you can see it takes 2 parameters. It takes a lat and a long, and we could type out those parameters. I save some space here, but those are probably both floats. And in this case, it returns an array. And that return value, we've got it named as an address over here. So first of all, in this function, we're using native PHP types. In the parameter list, these are both floats, and the return is an array. One of the challenges we run into in this functional program is this return value that we've named address. So we obviously know that it's an array because that's typed. That's the return type. But how is this structured? For example, how do I get access to the values that are inside, like the street value or the state value? For example, am I writing code like this, where I'm accessing by index and maybe that's the state value? Or am I writing code like this? So it's an associative array and I have an association with the keyword state, and that's how I get the state? Or maybe because Google's API has to be more global, they do something like province or something like that. But the challenge is we just do not know what that return type is. And yes, we have some control because inside of this function, we're calling out to the Google API and we're getting their response. And we'll probably repack that response into this array that's particular to our application. But we still have to have some internal knowledge of what's going on and how that's packed. We need to have that in order for us to use this function. Now, having that internal knowledge doesn't necessarily feel like it's an awful thing. But what can happen is if we change the implementation of this and we break that contract, it isn't so obvious that it's broken. If I rename inside here, I switch from state to province. So the code down the line has to always be aware of what that code change is that's inside of this function. And object-oriented programming can help address that. So now your boss comes along and says, we have to switch from Google's API to OpenStreetMap API. And they give you a business reason for it. And you say, okay, let's do this. And so now we have version 2 of our function. I have encapsulated the two implementations in two different files. So I have a Google Map API.php and I have an OpenStreetMap API.php. And I have this same function called. Everything looks pretty good. So I still have this issue with this array, and I need this internal knowledge to be able to unpack that. But the application can now require the OpenStreetMap API instead of the Google Map API. And to the users, they won't know where the address is coming from. And this really worked out well because I've encapsulated the two implementations into different files. And now the boss comes back in and says, we've got some feedback about the quality of the addresses. Some people like the old Google API and others are liking the OpenStreetMaps. Can you give the user a choice? And so for version 3, we're going to have a little bit of a problem because if I try to load both these files at the same time, I have a conflict with the names. This function is called get_address from lat long, and so is this one. So by loading both those files in at the same time, there's going to be a naming conflict. So one of the things we can do is we can rename our functions. So we can prefix our function names with Google_ and OSM_. And now it's possible to load both of these in at the same time. Now imagine downstream code. Earlier, I had downstream code. It was just calling this function. It was called getAddress from lat long. Now we have to have some logic somewhere in our code saying this user prefers Google API, so call this function. This user prefers OpenStreetMap, so call this function. So our code base here is just getting a little bit messier because I have these implementations. Now I have to have some logic somewhere that is going to determine which of these functions to call. I have to have them both loaded so they all have different names. And imagine that we scale this up so that there's not just 2 ways to get an address from a lat long, but maybe there's 10 different ways and we want to use all 10. And so scaling our code in this unstructured way can become a bit messy. All right, so let's switch over and talk about object-oriented programming. And we're going to solve the same problem using OOP. So what is object-oriented programming? So there's something called a class that encapsulates both properties and methods. You can think of properties as data, and you can think of methods as our standard functions. Now, a class is really just a blueprint, and we don't use classes directly, but what we do is we instantiate instances of those classes. Here is, for example, a number of different instances, and they all have different properties, so they could be different lat longs or different addresses, and the methods act just like our normal functions. They're internal to the object itself. And so you may have parameters that you have to feed in, and it can also access the internal data, so the properties. But let's solve this same problem. We have to convert some lat longs to an address. How would we do that in object-oriented programming? The first step in object-oriented programming is to create the blueprints or these classes that we're going to use to solve our problem. And you can see 2 data type classes. We have a GPS class and we have an address class, and each of these have properties. The GPS point has a latitude and longitude properties, and the address class has street, city, state, country, and zip. And you can see by having our address class as our result, we're getting this out of our API. We don't need to have any particular knowledge of what's going on inside the API anymore. It's returning an address class, and we already know that this address has these properties, and we can just access them. And then we also have this class that encapsulates the call to whatever API we're using. So this is the Google Map API. But we can encapsulate that, and there's just a get address method, and it takes a GPS point as a parameter, and it returns an address. So this is how we would start. We would create these blueprints. The second step is we would have to create an instance of each of these. So I'm going to create an instance of our GPS point, and I'm going to fill out the lat long. So I'm going to provide those values that the API is going to need. I'm going to create an instance of our Google Map API, and I'm going to feed it this lat long GPS point when I call the get address method. And then inside this Google Map API, it's going to create an instance of the address class, and it's going to return that with all of the properties filled out for us. That's version 1 of this application. Version 2, the boss does the same thing. Hey, there's OpenStreetMap. Can we use that instead? And we say, absolutely, for sure. And so for version 2, because we have this structure on how we can build these kinds of things, once I have one, if I'm asked for another one, then usually I have some options. In this option, we're going to create something called an interface. And that interface is, think of it as a contract. And that contract tells us how implementations or classes that implement this interface will behave. So for example, this particular interface is called Map API interface. It has a get address. It takes a GPS lat long and it returns an address type. And then you can see for version 2, we created this OpenStreetMap API. It implements that Map API interface. So it has a get address method. And then we also have changed and modified our Google Map API, so it now implements that Map API interface. And then our application, not much has changed. We have to create an instance of this GPS point class. And so we have that. We fill out the lat long. What changes now is I do not need a specific implementation of either Google Map or OpenStreetMap. Just what I'm giving my application is an instance that implements the Map API interface. I don't really care under the hood if it's Google or if it's OpenStreetMap. That is implementation detail, and I do not need to know at this application level that implementation detail. So it's abstracted away. So the application calls get address on this Map API interface object. Inside that, we know it's going to create an address and it returns the address. One of the things that we're all set up for is version 3. Our boss comes in and says users would like to select which version that they want. So in this object-oriented world, it's really easy for us to swap this OpenStreetMap API version for this Google Map API version. This is called polymorphism. We have different ways of doing stuff under the hood, but it's the same. For our application, it's the same. It doesn't matter if I get a Google Map API or an OpenStreetMap API. So in our application, it turns out that that's not a hard thing for us to do. We can create an instance of whatever type that the user wants, and we provide that into our application. That's a tabletop discussion of functional versus object-oriented programming. And you can see them here side by side. It's just two different methodologies. So when should you use the functional programming approach or the object-oriented programming approach? For small applications that you're the only author, you're the only one writing code, functional programming will work just fine. If you're in an ecosystem like WordPress or anything where you have multiple developers contributing code, I would highly recommend that everybody uses object-oriented programming from the get-go. Even if you're in an ecosystem like WordPress where maybe some of it's functional, you can still have your piece using object-oriented programming. And for any application, even if you're the only author where the code base is going to become large, you're going to integrate external APIs, you're going to have a lot of different features, then I would automatically start with the object-oriented programming. It doesn't hurt. My preference is I rarely write any functional programming code. I'm almost always writing object-oriented programming code. It just gives me the flexibility. I'm already in a position where that code base can expand and I can still have maintainable code.